For the past 100 years, scientists have trusted one story to explain everything about our universe. It says the universe began in a hot, dense instant called the Big Bang, roughly 13.8 billion years ago. It says space has been expanding ever since, stretched outward by a mysterious force called dark energy. And it says that most of the universe isn't made of stars or planets at all, but of invisible dark matter holding galaxies together like an unseen skeleton. Astronomers call this the standard model of cosmology. For decades, it has explained almost everything we've observed. But recently, in 3 separate places, the model has started to crack, and nobody is quite sure why. The first crack has a name: the Hubble tension. It comes down to one deceptively simple question. How fast is the universe expanding right now? There are 2 ways to answer it, and they don't agree. The first method uses the cosmic microwave background, the faint afterglow left over from the Big Bang itself. Using this method, scientists calculate an expansion rate of about 67 kilometers per second for every megaparsec of space. The second method is more direct. Astronomers measure the brightness of nearby stars and exploding stars called supernovae, then use that to calculate how fast galaxies are actually moving away from us today. This method gives a noticeably higher number, closer to 73. Those 2 numbers should match. They don't. For years, scientists assumed one of the measurements was simply wrong, and that better instruments would fix the gap. But newer data from the James Webb Space Telescope confirmed the higher number instead of correcting it. The disagreement has only grown sharper, now standing at a confidence level that professional statisticians take very seriously. If both measurements are correct, that means something is missing from the standard model itself. Some unknown physics in the early universe, or in the universe today, that nobody has identified yet. The second crack showed up in a place nobody expected: extremely distant, extremely young galaxies. When the James Webb Space Telescope began scanning deep space in 2022, it looked back further in time than any telescope before it, and it found something strange. Enormous, fully formed galaxies, already glowing with over 100 billion stars, existing just a few 100 million years after the Big Bang. According to the standard model, that shouldn't be possible. Galaxies that massive are supposed to take billions of years to build, slowly gathering gas and dust and merging with smaller neighbors. Finding them fully grown this early is like finding a fully grown oak tree the week after the forest was planted. Astronomers have nicknamed this the impossible early galaxy problem. Some researchers think our mass estimates are simply off. These galaxies may contain more faint, low-mass stars than we assumed, which would make the numbers work again. Other researchers think the early universe formed stars far faster than anyone predicted, and a small number of scientists wonder if this is a sign that our timeline for the universe's age is wrong altogether. The telescope is still gathering more detailed data to settle the question. For now, these galaxies remain exactly what their nickname says: impossible, at least according to the model we've trusted for decades. The third crack is the strangest of all, because it touches dark energy itself, the force believed to make up nearly 70% of everything that exists. For a long time, scientists treated dark energy as a constant, a fixed pressure pushing space outward at the same strength forever. But in 2025, that assumption was challenged. The Dark Energy Spectroscopic Instrument, a survey that has mapped nearly 15 million galaxies and quasars, released a new analysis covering the last 11 billion years of cosmic history. Researchers combined their measurements with other independent data. The cosmic microwave background, exploding stars, even the way gravity bends light across space. Every method pointed to the same unsettling possibility: dark energy might not be constant after all. It may be weakening over time. If that turns out to be true, It wouldn't be a small correction. It would change our understanding of how the universe will end. A constant dark energy points toward a cold, dark, endlessly expanding future. A weakening one opens up entirely different possibilities. Scientists are careful here, and for good reason. Evidence for evolving dark energy is strong, but it is not yet considered proof. More data is being collected right now to confirm or rule it out. So here's where that leaves us. 3 independent problems. A universe that seems to expand at 2 different speeds depending on how you measure it. Galaxies that grew up far too fast. And a force that was supposed to be constant, but might not be. It's tempting to think these are just measurement errors waiting to be fixed. Some of them might be, but it's worth remembering that science has been here before. In the 1990s, a handful of odd observations about supernovae led to the discovery of dark energy itself, an idea that seemed impossible until the evidence became undeniable. That's the strange privilege of studying the cosmos. It rarely tells us we were completely wrong. More often, it tells us we were only seeing part of the picture. The standard model of cosmology has explained an extraordinary amount about the universe we live in. It may still be mostly right. But right now, in 3 separate corners of the sky, the universe seems to be quietly raising its hand and asking us to look again. And somewhere in that gap between what we expected and what we're actually seeing, the next real breakthrough in cosmology is probably waiting. We're watching it happen in real time.